So, okay. Nakikita nyo naman tong syllabus ulit natin. So, last time, you were able to tackle LO 1.1 and 1.2. Meron akong sinend na mga advanced links sa inyo so that you can look at the differences between diesel engine and gasoline engine. Kasi related din naman siya sa spark and compression ignition. Pero ito ngayon, may advantages, disadvantages tayo. Then we'll also differentiate the 2-stroke versus 4-stroke cycle. Pero ito, diesel engine na lang. So that's going to be 1.4. And we'll see if we can also tackle LO1. Well, I think matatackle natin tong LO 1.5 kasi you will see the differences sa structure at sa construction ng isang marine diesel engine na 2-stroke versus sa isang marine diesel engine na 4-stroke, which is ipapakita rin sa video and I will also show you with our links. Okay? So, I think we can start off with ito, para mas madali siyang i-digest. Ito muna, mag-video muna tayo. Then, i-explain ko further yung ibang mga differences nila. So, yan.
The differences between petrol and diesel engines. We all know that diesel engines are lower revving and more fuel efficient than petrol engines, but do you know exactly how and why they're different? If not, then let this video be your ultimate guide. Petrol, aka gasoline, and diesel engines operate on the same 4-stroke cycle. This starts with the intake stroke where the piston descends, sucking air into the cylinder through open air intake valves as fuel is injected. This is followed by the compression stroke where the valves close and the piston goes back up the cylinder to compress the air and fuel mixture. The third step is the power stroke, where the mixture is ignited to force the piston back down the cylinder, and then the final exhaust stroke occurs where the ignited fuel and air mixture is pushed back out of the cylinder by the piston through the exhaust valves. Where petrol and diesel engines differ is how they ignite the air and fuel. To understand the difference, we need to understand the self-ignition temperature. This is the temperature at which an air-fuel mixture will ignite without the use of a spark plug, purely due to compression. It's this compression that allows the air and fuel mixture to ignite in a diesel engine without the need of a spark, because the greater compression, the higher the temperature. That's why diesel engines have higher compression ratios compared with petrol engines that don't compress the air and fuel mixture to the point of ignition. If you don't know what a compression ratio is, let me quickly explain. Simply put, it's the ratio of the maximum to minimum volume in the cylinder. So a ratio of 10 to 1 means that when the piston is at its lowest point, there is 10 times as much volume as when it's at its highest point. To give you an
Okay. So ito one of the things that you will have to be more particular about. Sige, wait lang. So you have compression ratio. Then, meron ka rin tinatawag na stroke. So, burahin natin muna ito lahat. Yan. Then, so, ito. Natin. Palitan natin ang kulay ito. Gawin natin siya itim. So, pag sinabi mo compression ratio, tapos meron din tayong tinatawag na stroke mamaya. Kaya siya stroke, di ba? 2-stroke and 4-stroke. So, kunwari ito yung ating oops. Yan lang. Wala. Yan lang. Nagkaroon ng may napindot ako. Ayan. So, this should be back to ayan, kunyari yan. Ito yung cylinder natin kunwari lang. So, let's say This will be, green is your highest. Kunyari ito. And sabihin natin red is your lowest point. So, gawin natin tong blue. Okay. Ngayon, pag sinabi niyang 10:1 ang compression ratio mo, okay. Narin, 10:1. Hindi masyadong kita yung ano natin. So, gawin natin siyang bilog. 10:1. Ibig sabihin, pag hinati mo to sa 10, etong nakikita nyong ano dito, yan, yung space na yan. So, ito yung minimum eh. Hanggang dyan lang siya. Kasi you need to make room for injection ng fuel mo. So, ito, this would be, itong size na ito, this would be 10 times of that. Itong, nakikita nyong chamber dito sa ibabaw, itong may kulay blue. Pag sinabi mong 10:1 yan, so ito yung minimum, then going to the maximum. Itong buong volume na to, this will be the 10 times of this particular volume here. So, yung maximum mo, nandito yung piston mo. Drawing tayo piston. Ayan. So, kunwari ito yung piston mo. Nandyan siya. Ito yung pinakamalaking volume niya. So, ibig sabihin, air will come inside. Tapos, as it goes up, compress niya. Hanggang dyan lang. So, ito, then saka nabubuga yung iyong injector. Kasi mainit na ito and it's enough to ignite. Ngayon, sir, ano naman yung stroke? Sige. So, yung stroke, pag sinabi mo stroke, ito yan, ito lang yun. Yung length na yan. Stroke yan. Yung haba lang. Kasi 'di ba pag tiningnan mo to, pag ginawa mo siyang cylindrical, so ito yung part lang yan, yan, to. Ito yung minimum mo, yan. Yung maximum mo, well, ano natin, scale natin. So if I'm going to make it cylindrical, ito yung magiging ayan siya. Ayan yung volume niya. Ngayon, itong haba niyan, ayan yung stroke mo. Yan lang. So, this is the distance traveled by your piston from your bottom dead, yung pinakamababa niya, up to the highest top dead. Nasusundan ba? Nasundan? Okay, so I'll just let me resume the video.
Example of compression ratios, a 2015 VW Golf TSI has a compression ratio of 9.6 to 1, while a 2015 VW Golf TDI has a compression ratio of 16.2 to 1. Again, a diesel will have a higher compression ratio to ensure that the air and fuel mixture is compressed enough to the point of ignition, while a petrol engine uses less compression and is ignited by the spark plug. Though no longer true for all modern oil burners, another significant significant difference with a diesel versus petrol engine is that diesels lack a throttle body. This means that when you press on the accelerator pedal, the fuel injectors simply supply more diesel to create more power. Petrol or gasoline engines, on the other hand, require a throttle body. As you press on the accelerator pedal, you open up the throttle and allow more air to flow into the engine. More air means the injectors send in more fuel, and more fuel means more power. Where petrol and diesel engines differ again is how they're able to engine brake, where you lift off the throttle in gear to slow the car down. In a petrol vehicle, engine braking is achieved because as you lift off the throttle body closes, creating a vacuum between the throttle body and the cylinders to slow the car down. In a diesel engine vehicle with no throttle body, engine braking occurs during the compression stroke, where the exhaust valve is open to allow pressurized air to escape. And the reason engine braking with diesel engines is so loud is because you're hearing that compressed air leaving the exhaust. So why exactly are diesel engines more efficient than petrol engines? One of the many reasons is down to the fuel itself. Diesel is comprised of more long-chain hydrocarbons, which simply means it's got more energy than petrol. In fact, it contains about 15% more energy by volume, roughly 36.9 megajoules per litre compared to petrol's 33.7 megajoules per litre. Diesel engines are also more efficient because of the thermal efficiency gains you get from igniting the air with high compression, rather than a petrol engine's lower compression ratio that requires a spark for ignition. The higher compression ratio, longer stroke, and typically higher turbo boost pressure of a diesel also allows it to produce more torque at lower RPM than a petrol engine, meaning that less fuel is needed to move a car. Another reason why diesels are more fuel efficient is their tendency to be turbocharged, and that's because a turbo feeds compressed air into the cylinder, which helps the piston descend into the cylinder, therefore saving energy. So now that you know the inner workings of a petrol versus a diesel engine, which one are you a bigger fan of? Let us know in the comments below, and remember to give this video a lovely thumbs up.
So, do you have any questions sa differences nila? Wala pa. Okay. Sir, bakit ganun? Nagpo-focus lang tayo sa diesel engine, hindi sa gasoline. Well aware naman na kayo sa presyo ng langis currently. Ngayon, if you look at vessels, they are running for days or even weeks at a time, dire-diretso. So, tonelada ang kinakarga sa kanya. Before Marpol 6, before Marpol Annex 6, yung air pollution, you can still run ships at heavy fuel oil. Yung heavy fuel oil, latak na yan. Malapit na sa asfalto yan. Pero sumisindi pa. So ngayon, yung emissions niyan, mataas ang pollution level, mataas ang sulfur. Nung na-enforce na yung Marpol Annex 6, bawal na gumamit ng high sulfur or normal sulfur fuel content. That's why they shifted to diesel. Compared to heavy fuel oil, mas mataas ang presyo ng diesel. Pero nga dahil bawal na gamitin ang heavy fuel oil sa puerto, they're using diesel instead. Okay? Bakit yung gasolina hindi po ginagamit? Kasi mas mahal din ang gasolina kaysa sa diesel. So sa kanilang tatlo, ang pinakamura yung HFO. Ang pinakamahal, gasoline. So magkano na ba ang presyo ng gasolina ngayon? Per liter.
Nasa 60 to 64 to 70 pesos.
Sabihin natin 65 on average. Sige. 65 on average, tapos dahil lang. Liters to tons tayo kasi ang mangyayari niyan, liters to tons, metric tons. Ito, liters na lang yan. Ay, not flow. Volume yan. So, you have 65 per liter, di ba? So, let's see kung ilang ano yan. Sabihin natin magkakarga na lang tayo ng ilang tons dito. At walang tons. Ay, wala rin. Cubic meters na lang. Sige, in cubic meters. Tingnan natin yung... Wait lang. So, cubic meters. Sabihin natin 1,000, ano na lang. Sabihin natin magkakarga tayo ng 2,000 cubic meters. Ayan, may nag-video pa na ano. Ang tagal mag-skip. Yan. Okay. So, let's say I will load up to 2,000 cubic meters. Okay? That is equal to 2 million liters. O, sige, computein natin. O, 65 times 2 million liters. O, 65 pesos times 2 million. Magkano yun?
130 million,
130
sir.
million, sir.
Yes, well, that's 130 million pesos on fuel alone. That would be enough for, sabihin natin, a 3-month voyage. That is if, kung purely diesel, hindi, gasolina yan, di ba? Oh, that is just if you're going to use gasoline on your ship. Ganun siya kamahal. Sipin nyo, gagastos ka lang 130 million pesos para lang paandarin yung buong barko mo on a 3-month voyage. So, kailangan talaga kumita yung barko mo niyan. That's part of your operating costs. Na ano nyo ba? Napipicture nyo? Yung, di ba? Nakakalula. Kaya natin pinag-uusapan diesel engine lang, hindi tayo nag-veer out masyado kasi ito yung ginagamit natin sa barko. Ito yung aabutan nyo. Wala pa namang, well, you can run, hindi pala. You cannot run a gasoline sa diesel engine basta-basta. Kasi, iba ang characteristics niyan. So, ito, papakita natin dito, 5 reasons why diesel engines make more torque. Ibig sabihin, mas malakas yung hatak ng diesel natin. So if you're going to move tons, thousands of tons worth of machinery, vehicle and cargo, ano mas pipiliin mo? Yung mabilis o yung malakas yung hatak? Kayo, ano pipiliin nyo?
Yung hatak
Yung
po,
hatak po, sir.
'Di ba? So, for example, sino dito yung mga nagmamotorsiklo? Sige, show of hands lang. Sino dito yung nagmamotorsiklo? Ayan, si Sapico, si Lagresola. So, di ba pag tinitingnan yung specs ng motorsiklo, di ba meron ka makikita ng foot-pound torque or minsan newton meter na torque, di ba?
Sir Aizen.
Sir, ay, sir.
Okay, sino dito na yung nakasakay sa tricycle?
Ako po, sir.
Ako po, sir.
Mamasada.
Mamasada.
O, yun, namamasada. O, si Sapico. Anong gamit mong motorsiklo?
Minsan, sir,
Minsan,
ano po,
sir,
barako.
barako.
Tapos, yung AX4 na Suzuki.
Suzuki.
Dalawa po, sir.
Dalawa po, sir.
Okay, ilang cc yun?
Yung sa
Yung
barako,
sa
sir,
barako,
175 po.
175
Tapos,
po.
yung sa AX4, 150 lang.
150 lang.
Okay, so they're actually very small engines, di ba? Kasi yung cc is cubic centimeter yan, yung volume, displacement niya. So, hindi ganun kabilis yung barako sa kayong gamit mong isa, di ba?
Sir Aizen.
Sir, ay, sir.
Pero, pwede mong kargahan ng ilang sakong bigas yan.
Mga ano,
Mga,
sir,
ano,
mga...
sir, mga...
Sa barako,
Sa
sir,
barako,
ano,
sir, ano,
tampo.
sir, 10.
10. So, that's,
Ay, sir.
sabihin natin, ilang ano yan? Ilang kilo? 25 o 50 kilos?
Yung alin po,
Ilan?
sir?
Yung alin po, sir?
Na sako ng bigas ang kinakarga mo?
Nasa 25 lang, sir.
25. Oh, so 25 times 10, that's 250. That's
Sir,
that's an extra 250 kilograms. Siyempre, hihilahin pa niya yung bigat niya sa yung bigat mo. So, roughly, hihila yung motorsiklo mo or yung engine ng motorsiklo mo ng at least 400 kilos na bigat or yung mass. Ganong kalaki yung hinihila niya. Nagigets nyo? Napipicture out nyo?
Okay, sir.
Diba? So, yung makina mo, required siya, hindi niya kailangan ng sobrang bilis. Ang kailangan niya, yung lakas ng hatak so that pwede siyang mapagdala ng maraming cargo per trip. So, mas matipid ngayon siya compared kung kukuha ka ng isang high-speed engine na mahina naman yung hatak. So, these are the rationales behind bakit diesel engine ang ginagamit. And later on, we will focus yung in-establish ko yung significance nung pag-aaralan na nating makina kung bakit hindi tayo lilipat sa jet engine, hindi tayo lilipat sa gasoline engine, but hindi tayo lilipat sa sasakyan. Though we will make them as examples kasi yun yung readily available sa inyo. So, okay. So, I'll play the video. If you have any questions, do raise them and or raise your hand or chat it in the chat box. Okay?
Hello everyone and welcome. You may notice that diesel vehicles tend to have higher torque figures versus their gasoline counterparts. So in this video we're going to be talking about 5 reasons why diesel engines tend to produce more torque versus gasoline engines. And we're going to start things off discussing compression ratio. So if you look at a gasoline engine, as that piston is moving towards top dead center, as it's moving upward, it's going to come to a stop sooner versus a diesel engine, which is going to continue to compress that air even further. So why does the diesel engine compress the air more? Well, this is because the diesel engine is relying on the heat of that air to instantly combust the fuel as it's injected in. So it's raising the air above the self-ignition temperature of the diesel fuel versus in a gasoline engine, you're compressing an air and fuel mixture, which you don't want to rise above its self-ignition temperature because you want to use a spark plug to ignite it rather than compression. So the gasoline engine doesn't compress quite as much to ensure that the temperatures don't get that hot versus the diesel engine wants that temperature to get really hot, so it compresses it even further. So what does this all translate into? Well, by using higher compression ratios, there's a direct correlation between the efficiency of an engine and how much torque it produces. So those higher compression ratios translate into more torque for the diesel engine. Next, we're going to talk about the speed of combustion. So in a gasoline engine, a spark, as mentioned, starts the ignition of that air and fuel mixture, and then the flame travels outward from that spark plug until it finally burns all of that air and fuel. Versus in a diesel engine, the fuel nearly instantly combusts as it's injected into the cylinder, so complete combustion occurs much sooner. So if you're to look at the pistons as they're moving downward, the gasoline engine, the piston has moved down a significant amount before complete combustion has occurred, versus the diesel engine, the piston hasn't moved down quite as much before complete combustion has occurred. And the result means that with the diesel engine, there's more time that fuel is spending pushing down that piston versus the gasoline engine, which translates into more useful work and more torque produced. So in the gasoline engine, if you still have combustion occurring when, the piston's way down here, that combustion is only going to be pressing the piston down for a short duration, versus if it happened up top, it would have pushed down that piston for the entire duration. So you want that immediate compression ignition property of the diesel engine to maximize how much torque you produce. Okay, so the third thing we're going to talk about is the bore versus stroke, and the fact that diesel engines tend to have a longer stroke length. So if you're looking at a gasoline engine, it's typically going to have a wider bore, but the piston isn't going to travel up and down quite as much, versus looking at a diesel engine, which the piston will travel up and down quite a bit, but the bore won't be quite as wide as on the gasoline engine. So torque is simply force multiplied by high distance. So in the case of a diesel engine, you've not only got a larger force, but you're multiplying that larger force by a larger distance, the distance rotating around that crankshaft. And so ultimately that's going to translate into more torque produced. So I've got a simple example here where we've got two engines which have the same displacement. This is a single cylinder, 0.6 liters, and we've got 120 millimeter stroke on the left with an 80 millimeter bore versus a 100 millimeter bore on the right and an 80 millimeter stroke. Both of those 0.6 liters, however, this one has a significantly longer stroke. Now I think it's worth mentioning that because combustion occurs much sooner in a diesel engine, it's going to be occurring when it's not at, the ideal angle for creating that force versus distance. So I'm not, totally convinced that stroke length plays all that much of a role in the overall discussion of producing more torque, but it certainly can help to have that greater distance. I think the fact that it has higher compression ratios and that it's turbocharged are ultimately going to be the biggest driving factors, along with that quicker combustion. So getting into this a little bit more, part of the reason that this limits a diesel's engine speed is that the piston has to travel very quickly if the stroke is super long. So right here I've got this example here where if it's spinning at 3,000 RPM, the average piston speed will be 12 meters per second versus the 80 millimeter stroke is going to be traveling at 4,500 RPM for the piston speed to be traveling an average of 12 meters per second. So both of these having the same average piston speeds, but this one able to rev up much quicker to a higher RPM without getting into super high piston speeds. Moving on to number 4, diesel engines tend to be turbocharged and they tend to be built for turbochargers. So they are using heavier components, iron blocks, heavy duty pistons, connecting rods, crankshafts. All of this results in a significantly heavier engine, but an engine that is built to be able to handle the increased amount of torque that diesel engines produce. And another thing about diesel engines is that they tend to burn quite lean. So they have a very lean ratio, air-fuel ratio, 18:1, up as high as 70:1 that they can operate in. And by burning lean, you can have more air to expand and create more useful work. Now that's more an efficiency gain, but also it leads to why diesel engines want to be turbocharged to help put in all that air to combine with the fuel, the less amount of fuel, but quite a bit of air that you're using to run efficiently. They also don't have the pumping losses associated with gasoline engines because they'll be throttleless or typically have the throttle almost always wide open, versus gasoline engines which operate in a much narrower air-fuel ratio range, and overall you're not going to see typically as high of boost levels because the engines aren't quite as built for those higher boost levels that diesel engines are from the factory built for. So again, more boost, more fuel equals more power and of course more torque. And finally, something I think worth mentioning is that the energy density of diesel fuel is greater than gasoline. So if you have the same volume of fuel, whether it's a gallon of gasoline or a gallon of diesel, that gallon of diesel is going to have about 10 to 15% more energy packed in it than the gasoline. So if you're spraying the same volume of fuel into a cylinder, that diesel fuel is going to produce more torque. So thank you all for watching, and if you have any questions or comments, please.
Ayan, so yung topic niya, it actually spills over sa mechanics and sa thermodynamics. Pero hindi pa kailangan masyado isipin yun. Tapos na ba kayo mag-mechanics sa thermodynamics? Tapos yun na ba yun? Alam ko hindi kayo yung hinawakan ko nun eh.
Thermodynamics.
Tapos na.
Hydromechanics yata yun, first year.
Alam ko hindi. Yung F1E. Kayo ba yung lang?
First year po yata yun.
Oh, first year yun eh. Pero okay, anyway, etong concepts na to, makikita nyo yung overlap sa mechanics and sa thermodynamics dito sa ating PPD. Ito na yung manifestation. Kaso nga lang, ang PPD natin is a much more specialized sa mechanical side, machinery. Yung thermodynamics and mechanics are more on the computational design. Hindi siya mismong gumagawa. So ito, makikita niyo yung concepts na yan, kung bakit PPD or diesel engine tayo nagko-concentrate kasi Mas ginagamit siya at mas hindi lang siya sa available, pero yung naipro-provide niyang convenience sa pag-move or pagpapaandar ng barko, saka yung paggamit niya sa generators is evident. So kung gagamit ka na lang ng mas mura, mas madaling mahanap, saka mas reliable, dito na tayo magfo-focus. Okay? Since it's already 16:40 at naka 30 minutes na tayo, so ito, meron tayong, actually ito sa mga previous nila na panood natin, na-highlight na sa kanila yung differences and yung advantages and disadvantages ng diesel engine versus the gasoline engine. Pero ito, it's more of the disadvantages of the gasoline versus the diesel. Mas marami advantages yung diesel na na pinapakita. I think we can go to the parts naman. Pero before tayo lumayo sa parts, kailangan mo natin ma-differentiate yung 4-stroke and 2-stroke. Ayan, hintayin lang natin ito mag-play. Mamaya natin yan.
Today we're going to talk about
Wait lang.
two-stroke
Mamaya yan. Ano'y muna natin tong isa.
You probably have some knowledge of how internal combustion engines work. They involve pistons, cams, explosions, etc. But do you know the difference between two-stroke and four-stroke engines? Throughout the history of automotive design, there have existed two main types of gasoline-powered combustion engines: the two-cycle, or two-stroke, and the four-cycle, or four-stroke engine. As you may have guessed, the names of each engine suggest exactly how they operate. For an engine to complete combustion, there needs to be combustion of the air-gas mixture and expulsion through the exhaust part. The way this process is repeated varies between each engine type. A two-cycle engine completes a combustion and exhaust cycle in only 2 strokes of the piston, whereas a four-cycle engine takes 4 strokes of the piston, thus their names. For a four-cycle engine, there's a power stroke where the piston is down, which is caused by combustion of the fuel mixture. Then there's an exhaust stroke where the piston is up, which pushes the gas up and out of the engine. The following 2 strokes include an intake, where the piston is down to draw in the fuel, and a compression stroke, where the piston is up to start the process all over again. Examining this process closer yields the observation that the whole cycle is powered by the initial combustion stroke. This means that the combustion of the fuel mixture needs to impart enough power on the piston to allow it to rotate the crankshaft twice. A two-cycle engine, on the other hand, has much simpler mechanics, as it basically consolidates the different processes of a four-stroke engine. There is a power stroke, which also releases the exhaust after a certain amount of travel, then an intake and compression stroke that draws in new fuel and completes combustion. These are the basic mechanics of each engine type, but both have significant advantages and disadvantages, which has ultimately led to a more widespread use of the four-stroke engine. Looking first at efficiency, a four-stroke engine achieves great efficiency due to the fact that nearly no fuel is wasted in the intake cycle. In other words, the fuel is drawn into a closed system. In a two-stroke engine, since the fuel is drawn in during a combined intake and compression stroke, the mechanics needed for this also means that some fuel can escape while being drawn into the cylinder, thus decreasing efficiency. Modern two-strokes use fuel injection, which increases
increases their efficiency to levels close to 4 strokes, but generally, a 4-stroke can be much more efficient. Efficiency isn't everything, though. A 4-stroke is certainly more efficient, but they also weigh upwards of 50% more than a comparable 2-stroke engine. This weight is due to more complexity within the motor's mechanism, which also leads to significantly more moving parts in a 4-cycle engine. In terms of simpleness and easiness to fix, a 2-stroke engine easily wins out. The last main difference between these engine types is how oil is added to the engine. In a 2-stroke engine, the oil is typically mixed with the fuel, usually somewhere in a 50-to-1 to 20-to-1 range. This makes oil application fairly reliable, but it also means increased fuel cost and fuel modification when you buy it. A 4-cycle engine uses normal gasoline like your car, which also happens to be a 4-stroke engine, and the oil is injected from a separate reservoir. This eases the burden of fueling the engine up, but of course there's always the possibility that the fuel pump will break. All things considered, even with the drawbacks of the 4-stroke, 4-cycle engines maintain higher efficiency over 2-strokes and can produce more power than comparable 2-stroke engines. There have been cars made with 2-stroke engines, but they mostly died off in the early 1980s due to efficiency constraints. Modern 2-stroke engines are still produced for small watercraft and gardening equipment. Sometimes simple design, like the 2-stroke engine, doesn't always beat out more complex mechanics. Thanks for watching. If you enjoyed this video, you can watch more.
Ayan. So, in this case, pagdating sa sasakyan, mas favorable ang 4-stroke engines mo. Pero for larger marine diesel applications, we are actually using 2-stroke sa main engine and 4-stroke for your generator. So, ito yung magiging katunayan niyan. So, ito yung makikita nyo mismo sa barko. Okay? So, do you have any questions? Sige, kung
Wala pa naman.
Wala pa? O, sige. Ipa-play ko muna to, then later on we can discuss it further. Okay? Sige.
Engine versus the 4-stroke engine. Ngayon, dalawa yung klase ng diesel engine na makikita natin sa barko. The first one is the 4-stroke cycle diesel engine. Itong 4-stroke diesel engine, ang applications nito sa barko ay yung mga high speed. Kasi ang 4-stroke engine, it usually rotates at medium speed between 250 and 700 RPM or greater than that. The applications of this 4-stroke diesel engine on board ship is the diesel generator. The diesel generator runs usually on board ship at 900 RPM. So this diesel generator sa 4-stroke diesel engine. Tapos nakakouple siya doon sa alternator. This alternator, if coupled with the diesel generator, it cuts the magnetic flux, then it produces the electromotive force or voltage, kaya nagkakaroon siya ng kuryente. Ngayon itong diesel generator natin, dahil 4-stroke siya, mas mabilis siya sa 2-stroke. It runs 900 RPM, and mapapansin natin sa diesel generator, may mga komplikado siyang valve mechanism, intake and exhaust valves. Tapos mabilis yung ikot niya. Tapos maliit lang din siya. Tapos yung 2-stroke diesel engine naman, the application of this usually sa main engine natin. Makikita natin yung main engine natin, napakalaki. Pero 2-stroke engine lang yung gamit niya. Ang principle niya lang ay 2-stroke cycle engine. Now, the main difference between these two cycles, between these two engines, is mainly the power developed. is the number one main difference, the power develop o yung power na kayang ibigay ng engine. How the power develop is the main difference. Una, the two-stroke cycle engine, meron siyang one power stroke every one revolution. Ganun ang two-stroke cycle. Two-stroke cycle is completed with only one revolution. And it has one power stroke at one revolution. While the four-stroke cycle engine, bago niya makompleto yung cycle, kailangan maka 2 revolutions muna siya. But in 2 revolutions, it has only one power stroke. So, nakita niyo yung difference. Sa 2-stroke cycle, one power stroke per 1 revolution. Pero sa 4-stroke, one power stroke per 2 revolutions. Yung power stroke, yung dyan nagkakaroon ng combustion. Ngayon, theoretically, the 2-stroke cycle engine will develop twice the power of a 4-stroke engine of the same sweep volume. Yung sweep volume na yun yung volume na trinavel multiplied by the area ng bore o yung diameter ng piston ng cylinder. Tapos yung stroke area ng bore tapos multiply mo yung stroke. Yun yung sweep volume niya. So nakita niyo yung diferensya. Bakit nga naman gagamit ka ng 2-stroke cycle engine sa main engine mo kung makapag-develop naman to ng twice the power of the 4-stroke.
Okay, sige. Parang medyo nagsuslurge siya dun, pero okay lang. Sige, let's focus on that first. Yung power requirement. Okay. Yung 4-stroke is naturally mas mabilis kaysa sa 2-stroke. Ilang revolutions ang nakukumpleto niya per cycle? Sa 4-stroke. Nakakailang akyat baba siya sa isang cycle? Ilan? Tawanin natin ha. So if you remember, ito yung stroke, ito yung length na yan. So kung 4-stroke yan, ilang akyat baba yan?
Dalawa, sir.
So 4-stroke, 1, 2, ganun lang?
Apat.
Apat. So 1,
Dalawang
2, 3, 4. So dalawang balik. Sa 2-stroke, ilan?
Dalawang kit base tapos isang
Ayan.
cycle.
1, 2. Ganun lang yung sa 2-stroke. So sa dalawa, sino mas mabilis? 4-stroke or 2-stroke?
4-stroke, sir.
Okay, 4-stroke. Ngayon, sige. Sabihin natin meron kang malaking sabihin natin size comparison. Sino mas mabilis gumalaw? Yung maliit na tao o yung malaking tao?
Yung maliit.
Yung maliit, no? Mas madaling gumalaw pag mas maliit. Okay. What if gagawin ko yung bilis ng maliit ng tao, yung bilis ng maliit na tao, ipapagawa ko dun sa malaking tao. Ano kaya pwede mangyari?
Hirap, sir.
Ha?
Hirap, sir.
Yes.
Parsado sa
Yes. Mahihirapan yung malaking tao kasi given their body parts, given the nature of their yung mismong composition, yung material sa bumubuo sa kanya, it is probable that the joints won't be able to handle having a massive body and moving at high speeds. Isipin nyo, elepante na kasing bilis ng koneho. Imagine niyo na lang kung gaano kadelikado 'yon. Kung ganun kalaking hayop, nas kasing bilis ng isang kuneho. 'Di ba? So, that's very dangerous. Ngayon, sa main engine, kaya 2-stroke ang gamit mo kasi it doesn't need too much of a speed. Kailangan niya mas malakas sa hatak, and at the same time, it's more favorable kung mabagal yung galaw niya. Mas mabagal yung akyat baba. As opposed, kung 4-stroke yan, sobrang bilis, kung malaki, at mabigat yung material, mahihirapan huminto yung makina. Because if you remember your physics, may inertia pa rin yan.
Hi, sir.
Tutuloy-tuloy pa rin ang andar yan. So, parang katulad ng classmate mong malaki na pag tumakbo, hindi siya makakapigil kagad ng hinto, at pag humarang ka sa dinadaanan niya, masasagasaan ka. So, it is also the same principle that is used in the selection of your propulsion plants or yung main engine mo or yung generator mo, mga prime movers and propulsion plants. Yan ang ginagamit natin. So, sige, patapusin natin yung video. Malinaw ba yon? Malinaw siya?
Ay, sir.
Okay. Sige.
Cycle engine of the same machine dimension. So, impractical na yung 4-stroke dun sa malakihang main engine. Pero ang 4-stroke cycle engine, ginagamit din na main propulsion, ang alam ko sa mga cruise ship, because they have 2 or more main propulsions. Kaya 4-stroke ang ginagamit nila doon. Pero sa mga karamihan ng mga barko, 80%, 2-stroke cycle. Number 2 difference. Mas magaan yung 2-stroke engine kapag binafacture siya kaysa doon sa 4-stroke engine of the same power. So, sa barko, kina-consider yung weight. So, mas malaki yung weight ng barko mo, mas ma-aksaya yan sa fuel consumption. So, kaya naman, yung 2-stroke cycle engine, ginagamit sa main engine. Yung 4-stroke, dun lang sa generator. Tapos, number 3, the 2-stroke cycle engine, it doesn't require complicated valve operating mechanisms like the 4-stroke engine na may intake, exhaust valves, tapos may valve bridge pa yan. Masyadong complicated na. Pero sa 2-stroke, isang spindle lang because it's sa scavenging process. So, mas less complicated sa 2-stroke. Pero, ang 4-stroke engine, however, can operate efficiently at high speeds. So, ang advantage naman niya, kaya ginagamit siya sa mga high speeds, kasi it can operate at high speed efficiently. So, which offsets its power disadvantage over the 2-stroke cycle engine. And it consumes less lubricating oil than the 2-stroke cycle engine. Because the 2-stroke cycle engine, meron pa siyang cylinder lubrication. So, mas maano siya sa lubricants. Kaya naman diesel generator, 4-stroke ang ginagamit niya dahil ang alternator natin, it requires higher speed. So, mas practical na 4-stroke engine ang gamitin mo kaysa sa 2-stroke engine. Ang 2-stroke engine is low speed yan eh. Mabagal yan. So, mababa yung RPM yan. Usually, nasa 82 RPM lang yung 4-stroke engine. So, those are the differences.
Wait, correction ha. Ang inyong 2-stroke marine diesel engine is low speed. So that's less than 100 RPMs at any given point. Ngayon, kailan lang umaandar ng 100 RPMs yan? Kapag sinasagad lang. Pero hindi mo naman ginagawa yung pagsagad yan. So, usually, papalo ng mga nasa, 80. 80 RPMs. 80 to 90. Yan ang healthy range ng inyong two-stroke low speed. Ngayon, medium speed mo, yan, mga nasa, ang medium speed mo kasi is nasa above ng 90 yan. So, sabihin natin mga 100 to 900 RPM, which is your diesel generator. Medium speed yan. Yung mga high speed mo, yan ay pumapalo ng 1,000 and above. Yan, yung range na yan. Anyway, you can look it up in Google. I'll also look it up in Google pag nakakuha na tayo naibalik na yung lesson materials nyo. So, yun yung tatandaan nyo Okay? So, low speed, mga below 100. So, 80 to 90 ang kailangan sa low speed mo sa main engine. Yung generator naman would range from 100, so above ng low speed, so mga 100, 200, up to 900. In your case, the generator is running up to 900 RPMs. 900 revolutions per minute yan. Okay? Malinaw ba?
Hi,
Do you
sir.
have any questions?
Right.
Wala naman. Okay. So, we can actually look at the mamaya na itong video. Matagal to Kaya makita natin yung parts. So, ito. So, ito. You have a two-stroke diesel engine.
Sir, pwede po pa-zoom.
Oo, syempre naman. Nakaya natin siya. Ito, mas okay yan. Ganito kalaki, no? Yan. Tingnan din natin to. Ito, zoom din natin. Ayan. Nababasa nyo ba? Ayan, mukhang mas okay. Ayan lang. I-zoom in muna natin.
Kita po.
Ayan, ito kita na rin. Ito kita na. So, lahat naman to isa-send ko sa inyo later on. So, ito. Ito muna tayo sa two-stroke. Oops. Ayan. So, ito. Makikita nyo yung sige, lilipat ko on the other side para side by side ang comparison. Ayan. So, ito yung cross-section niya. Ito natin onte. Yan. So, makikita nyo yung ito. One of the main defining features ng two-stroke and yung four-stroke mo is sa two-stroke may makikita kang crosshead. May crosshead yan. So, you have a piston rod, crosshead, connecting rod, crankshaft. Sa iyong four-stroke, you have a piston, connecting rod, crankshaft. So, sa structure pa lang, may makita na kayo kagad na difference. Ngayon, dahil low speed ito, okay lang sa kanya na may mahabang material siya as a guide. Pag masyadong mabilis to, this will risk breaking kasi maraming joints yan Ito, you have fewer moving parts dito sa side ng piston, so you can let it run at higher speeds. Pero ang difference din naman nila, unlike here sa cylinder head nila, meron kang hiwalay na exhaust valve, intake valve. Unlike dito sa iyong two-stroke, you just have this exhaust port, isang malaki yan, tapos meron kang air inlet ports na dito. So, there are no moving parts. Unlike here, you have an intake valve and exhaust valve na nag-a-allow ng entry of, ang intake mo is allow the entry of fresh air. Exhaust valve is allowing the exit of your exhaust gases. So, yan. So, side by side. Then, makikita nyo rin dito. So, ito pareho lang yan eh. Ito lang din yan eh. Ito, yan. You will see ito marami itong mga articles sa dito. So, hindi ko na rin di-discuss lahat in full detail so that you have something to read. Ito yan oh. Yung low speed is 80 to 100 revolutions per minute. RPM. 4-stroke mo na medium speed, that is 250 to 750. Pero ito kasi sa pag lumampas ka na dito, mapalo ka na ng, ang alam ko, ang medium speed pa rin ng ang generator mo eh. So hanggang 900 dapat yan. Pag pumalo ka na ng 1,000 pataas, na yan? High speed na yan. Yun na yung ginagamit sa mga sasakyan. So ito, connecting rod to. Sir, may ganyan ba kalaki? Yes. May ganyan kalaking mga connecting rod. In fact, maliit pa nga yan, sa totoo lang. Di ba wala siyang connecting rod? Ay, hindi, meron pala. Meron siyang connecting rod, walang piston rod yung 4-stroke. Yung connecting rod ng 2-stroke mo, maliit pa to. Maliit pa yan. Pero wala pa naman nakita sa ganito, sa generator na ganito kalaki. So, ito yung itsura ng crankshaft natin. So, makikita yung meron siyang mga counterweights. So, yan, nagva-vary ng itsura yan kada manufacturer. So, scroll down natin siya. So, ito yung mga So, nandito yung mga articles na makakatulong sa inyo for the various parts of the main engine of your 2-stroke. Ayan. Okay, wait lang. Tingnan natin to. Ito yung lipat natin dito sa kabila para may side by side comparison kayo. Ayan. Okay. So ito, ayan, may colored kayo ngayon. May colored picture kayo. Makita nyo yung scale niya ng gaano kalaki yung tao versus dun sa main engine. Ito mukhang malaki rin to. Kasi meron siya hagdanan, yan. So, ito yung ginagamit sa mga generators natin. Ayan. Kasi most likely generator to. So, yung tao mo, hanggang dito yan sa may hagdan. Dito sa railing, sa ganyang katangkad. So, yan yung itsura ng ito, pag nakakabit dito ang iyong high speed, medium to high speed na prime mover, kailangan mo ng gearbox. Kailangan mo ng gearbox kasi mas mataas yung revolutions nitong generator, yung prime mover here, yung 4-stroke mo, kumpara dun sa kailangan ng propeller. Unlike sa 2-stroke, the two-stroke can be directly connected to your shaft and your propeller. Kasi, mababa lang yung RPM na requirement sa kanya. So, ito mas malaking reference. Ayan. So, ito yung cycle niya. Which is later on, i-ano natin to. We'll tackle this. So, do you have any questions? Ito sa 4-stroke mo, may mga rocker arm pa. So, ito yung cycle naman din niya. So, makikita nyo magkaiba ng, ano yan, ng cycle. So, ito, this is a graph showing 360. So, you can imagine na ito yung galaw ng crankshaft mo. Yung pag-ikot niya. That is also translated to your reciprocating. So, dito naka-indicate yung angle. So, ibig sabihin nito, pag ito na yung angle, paakyat na yan. Ito, so makikita mo ito yan, oh. Compression, paakyat yan. From this side, paakyat, nagko-compress. Injection, tapos fuel, then, yan, mag-expand yan. Tapos ito naman yung exhaust. So, yan. Well, kaya nga siya tinawag na cycle kasi iikot siya. So, later on yan. Pero maganda na simulan nyo na makita. So, ito yung mga major parts na sa piston sa iyong 4-stroke. Tingnan natin kung meron din siya sa ito, meron siyang ano, may working animation siya. So, yeah, nakikita nyo ba yung change in colors? Yung kanyang intake, compression, then power, then exhaust. Okay. So, I believe it's 17:25. I'm going to give you a 10-minute rest break para hindi naman kayo sunog na sunog. So, come back 17:35.
Ay, sir. Sir, yung ano ba dito? Yung parang yellow-green? Fuel yun, sir.
Saan?
Yan po sa ano. Dito
Ito,
sa...
ito?
Hindi po, yung parang nasa maliit pataas, sir. Tapos bumababa doon sa may piston, sir.
Ito, dito yung color na yan. Charge air yan, hangin yan. Ang fuel mo itong dilaw. Yung oil mo, dilaw yan.
Color
Nag-spray sa
yellow,
loob.
sir.
Yun yung, ano mo, yun yung fuel mo. Yung kulay pula, that is your exhaust. Yung nakikita nyong blue and green dito sa ilalim, that is your charge air.
Okay, sir. Thank you po.
Okay, sige. Oh. Take your break muna.
The stroke of the engine, that is the distance from top. The engine itself is only ever going to operate at speeds up to about 100 RPM, which sounds quite slow, but if you consider that the stroke of the engine, that is the distance from top dead center to bottom dead center that each piston has to travel, is 2.5 meters, that's 8.2 feet, then 100 RPM is quite a lot. In terms of speed, you might reach speeds of up to about 23 knots. A knot is a nautical mile. If you want to figure out what a knot is in miles, you times it by about 1.15. So if we are traveling 23 knots, then we would reach a speed of about 26 miles per hour. That's about 43 kilometers an hour if you like to work in metric units. I appreciate that sounds pretty slow, 26 miles per hour, but it's still over 600 miles per day, or about 1,000 kilometers a day. Because ships travel day and night, and if you leave a port like San Francisco and you want to go to Japan, there's not many reasons to stop off or slow down on your way there. So let's now take a look at our large two-stroke marine diesel engine. We'll start off by looking at some of the outside parts. We've got an exhaust gas manifold. That's this silver item. The exhaust gases pass out of the top of the cylinder. They actually come up through this channel and then into this hole. And the exhaust gases would go through the hole and then into the manifold. Exhaust gases are fed to a turbocharger because this is a turbocharged engine. Turbocharging the engine increases efficiency because when the engine is running, it tends to run constantly for potentially a long period of time. If we take our example of traveling from San Francisco to Japan, then we may be at sea for 10 to 14 days. It really depends upon the speed that you're traveling at. If we pass the exhaust gases to the turbocharger though, down through here, we can compress the incoming air. Air actually gets sucked in through these filters here in the turbocharger, and then we pass that compressed air into a cooler. This would be our air cooler, and then the air cooler discharges the air into our air manifold, what we call our charge air manifold. That would be this space inside here. How much air do we need? A lot. Not just depending upon how fast the engine is going, but generally just quite a lot. I used to have to walk around the engine room and I'd walk around measuring the pressure differential across the filters here that were on the turbocharger. And normally there's not so much space to walk past the turbocharger here because there might be a railing or something that makes you walk quite close to the turbocharger filter. What actually happens is you walk past, and as you walk past you get sucked onto the side of this filter, and if you wanted to, you could give it a little hug almost, and you'd really feel it trying to suck you into the engine. When you walk past with a clipboard, it tries to suck the paper off the clipboard. I used to actually have quite a cool trick that I used to do when I did my engine rounds, or the rounds as they're called. I used to take the piece of paper I was working with, and then I'd just stick it onto the filter while I went round the other side of the turbocharger to check the differential pressure across the turbocharger filter. Then you could just go back over here and pick up the paper off the side of the filter, which had remained stuck because of all the air being drawn into the engine. The reason you measure the differential across the filter is because at some point the filter gets dirty and you need to change the filter. As the filter gets dirty over time, you end up with a larger differential pressure across the filter, that is to say a larger differential pressure measured on the outside of the filter compared to the inside, and that's what tells you when it's time to change the filter. The filter itself is just filter cloth, and usually you can just wrap it around the turbocharger air inlet. Let's keep going though, because we're getting a bit sidetracked by details here. We pass air down to our air cooler, and then we need to cool the air. We're going to use water to cool the air, or cooling water, and the reason we cool the air is because we want the air density to increase. We don't want to cool the air too much because then we get drops of moisture in the air, so typically we'll cool it down to about 40 degrees Celsius, and not much further. In terms of pressure, we may have about 1.5 bar, which is about 20 psi. Once we've compressed the air to increase the air density and cooled it again to increase the air density, then this oxygen-rich air is fed into the charge air manifold. We call it charged air because it's passed through the turbocharger, and this charge air will then be fed into our combustion space, or our combustion cylinder. So it will come from this direction here, and it will actually travel up and straight in to the combustion space. So we're inside the combustion space, or the cylinder, and we've got this long piece of cylindrical steel, which is inside our combustion space as well. That is our piston rod. Below the piston rod, we have a connecting rod. This differs from most combustion engines, especially small and medium-sized engines, because they don't actually have a piston rod and a connecting rod. They have a connecting rod. Another name for a connecting rod is a conrod. In between the piston rod and the connecting rod is a crosshead. That's this sweet wrapper-shaped item here. Come across here, we can see the guides. The guides fit into these items on the side of the engine. can see the right angle where they slide along the guides, and that's to hold the crosshead in position and keep it moving along a linear path. Due to the size of the engine and the relatively small bore, the bore of the piston, the bore is just the diameter of the piston, but due to the small bore and very long stroke length of the engine, we need to have this crosshead. If we didn't have the crosshead, the very large pressure that builds up when we get our combustion, let me just move this piston out of the way. When we get our combustion in the space here, there's a huge amount of pressure, and that's going to force the piston downwards. We want the piston acting in a linear direction. That's why this piston rod is installed within the engine in a straight line. It's parallel with the cylinder. In smaller engines this isn't the case, but with larger engines we have to do this because the bore is so small compared to the stroke length, and because we don't want these loads being applied onto the crankshaft at an angle. You can see that occurring here with the conrod, but the conrod is much shorter now because it connects only to the crosshead. If we didn't have this arrangement, then what we'd end up with is a very long connecting rod that would have to stretch from the top of the piston, so say the piston head here, all the way down to where it connects with the crankshaft, so this place here. That's quite a large distance, maybe about 4 meters I would say, and that's simply too long. So the piston rod connects to the crosshead and the connecting rod connects to the crosshead as well. The connecting rod then connects to the crankshaft, and the crankshaft will connect to our propeller shaft. After that, the propeller shaft connects to the propeller, but only after it's been passed through several bearings and what they call a stern tube seal. The stern tube seal is what stops water entering the vessel through the space between the propeller shaft and the ship's hull. You can see we've got little ladders here. These are the rungs of a ladder, and here's another one. These get very slippery. You can climb into the crankcase and use these rungs to have a look around inside the crankcase. What's actually going to happen is you enter through the crankcase doors. I'm just going to go through this one here. And then you can climb around and inspect the area. Maybe you've got to disconnect. Let's just imagine for a moment we've got to disconnect the piston rod from the crosshead. So we'd need to get into this space here, and then you all stand around, hook up some hydraulic bolt tensioners, and then you have to try and undo the nuts using this hydraulic equipment, and then you can separate the piston rod from the crosshead. Notice on the other side, go over here, this item is not a crankcase door. Let's just go out of the engine. You can do a little spin. So what is it? If it's not a crankcase door, why do we even have it? You can see there's quite a few of them. Well, the reason we have them is because they're what are called crankcase explosion doors. I know, doesn't sound very good, does it? Another name for them, which sounds slightly less terrifying, is crankcase pressure relief valves, PRVs for short. Why do we have them? Well, inside this engine, there's going to be lubrication oil. A lot of it. Tons of it. Usually sitting at the bottom of the engine here, but also covering all of the internal surfaces of the engine, especially within the crankcase. If this oil gets heated up, maybe there's a hot spot between the bearings. Let's just say for a moment where our conrod connects to the crankshaft. There'll be a bearing that we can't see, about here and here. And if this bearing gets hot, it heats up the lubrication oil, and you end up with lubrication oil vapor. This vapor then begins to accumulate, let's just imagine, in the top corner of the crankcase here. And this cloud of oil vapor will get bigger and bigger. And eventually it might actually reach back onto the hot spot that originally created it. If this happens, we might end up with combustion. If that happens, we might end up with an explosion. And if that happens, then all of these valves on the side of the engine here are designed to pop open and relieve the pressure in as safe a way as possible. The alternative to relieving the pressure in this manner is that the doors get blown off the engine and the crankcase maybe explodes. The other disadvantage when this occurs, and it used to happen in the past before they started using these pressure relief valves or pressure relief doors, is that after the initial explosion, air is then free to enter into the crankcase, and you end up with another explosion, and it's bigger than the first. This scenario has killed engineers in the past, which is obviously not good, because the last thing you want to happen when you're walking around in the engine room, maybe you're doing your rounds at 4 o'clock in the morning, is to walk past here and then have the engine explode. So to try and stop this occurring, you'll constantly sample the air within the crankcase, and if the oil vapor level becomes too high, if there's a bit too much oil in the air or suspended in the air, then you'll get an alarm and you can slow the engine down or even shut the engine down. If for any reason that doesn't occur and you do have an explosion, at least you have these pressure relief valves or these pressure relief devices on the side of the engine, and they can relieve some of the pressure in a safe manner. When you go into the crankcase, it's actually quite funny because you put on these white paper suits and that stops you carrying any dirt and grit, etc. into the engine. And then you go inside, and the first time I went inside, nobody bothered to tell me that everything's covered in lubrication oil and just how slippy it is. So you reach into the crankcase, let's just say we're going in here, you grab hold of the ladder there, you put your foot on the ladder rung that's a bit further down, and then you put your weight on your foot, and then your foot slips, and you end up just hanging on for dear life with your one hand on the rung of the ladder up here. It's incredibly slippy inside because everything is coated in very slippy lubrication oil. Despite this, it's always good to go inside the engine. It's always quite a unique opportunity because how often do you ever get the chance to walk around inside an engine? So we've talked about some of the main parts. Maybe we should have a look at what happens when we start the engine. We don't start the engine with a starter motor or anything like that. You can turn the engine over very slowly using what's called a turning gear, and it will move a lot slower than this. Typically it's going to take over a minute for the engine to do one complete rotation using the turning gear. But you can see now that the engine is running. If you want to increase the speed a little bit, maybe we can add some more fuel. And then we can pause the engine again. I mentioned that we can use a turning gear to turn the engine very slowly. The reason we do this is because when we start the engine, we use compressed air. We're going to feed compressed air into the combustion space in order to drive the piston downwards towards the crankshaft. So let's imagine for a moment we feed compressed air into the engine. The piston is pushed down, and we need to give the piston momentum, all of the pistons, in order that they can draw air in and then race back up. And that's what gives us our initial compression ignition cycle. Once we have injected fuel into the combustion space, the engine then no longer requires compressed air. It can keep going using the momentum that it gets as we inject fuel and get combustion. But in order to get that initial momentum, in order to get the compression and the high temperature and pressure rise that we need in order to get combustion, we use compressed air. It's called a compressed air starting circuit or start air.
Okay, so I think that already goes too far sa ano natin, sa starting na yan eh. So, any questions about the parts or any observations dun sa nakita nyo sa loob ng ating main engine? Do you have any observations? Sige lang, before ko kayo i-dismiss. Sisend ko naman tong video link, then you can finish it on your on your free time. So, any observations ang napansin nyo dito sa ating main engine? Ito kasi ang aabutan nyo pag sakay nyo ng barko as cadets. Yung sinasabi niya na yan, yung may hagdan dyan, akitin nyo yan. Ako, pinapasok ko yan dati. Pag nagbubunot piston kami. Dito kami sumasakay dyan sa crosshead. Tapos tinatanggalan namin ng stuffing box ito. Yan. So, do you have any questions or do you have any observations? Tingnan nga natin kung na-hit natin yung ating learning outcomes. So, actually, tinamaan natin the differentiation ng 2-stroke and 4-stroke. Advantages and disadvantages actually naibigay din. Yung 1.5, so different parts of the diesel engine, ito, 2-stroke. Nasimulan na natin. Sa next meeting natin, sa lecture, itong 1.6. Yung laboratory, we will familiarize with the Kongsberg simulator program. Then we will start by just running the generators from cold ship tayo. Okay? So I'll be looking forward to seeing you tomorrow. If there are no more questions, no more observations, sige, you are now dismissed. So, ingat sa pag-uwi and please stay safe.
Thank you po.
Thank you po.
Okay, thank you. Okay, you are now dismissed. O pwede na kumalas. I'll just send all the links and the details later.
Sir, thank you.
Salamat.
Sir, thank you po, sir.
You're welcome.